This video is going to continue teaching solids or revolutions. And if you didn't watch the video on the disk method, then you should go watch that. Go to our channel, or I'll link the video in the description. But after you watch that, or if you already know the disk method, this is the washer method. So the disk method focuses on things that are rotated around the x-axis, where the shaded area that you're rotating is touching the x-axis. So you're rotating around where your shaded area ends. But let's say you have two functions. Let's say this is f of x and this is g of x, and this is the shaded area that you're trying to rotate around the x-axis. So what it's going to look like is, let's say you do your basic disk method first, but there's going to be a hole in the middle that's cut through because of this unshaded region that's still above the x-axis that's also being rotated. So it's kind of hard to draw a picture on this, but just think about it as your disk method, but there's also a hole cut through the middle that's also another disk that you're subtracting. So we already know that the formula for the disk method is pi times the definite integral from a to b of f of x dx, but for the washer method it's kind of different. We can still have this because this is f of x and we're rotating that, but we also have g of x. And when we rotate g of x, the definite integral of g of x around the x-axis, oh, this should be squared by the way, then we also have to subtract that area. So it's going to be subtract pi times the definite integral from a to b of g of x squared dx. And so now we can just combine these into one. So pi times the definite integral from a to b of f of x squared minus g of x squared dx. And that is the formula for the washer method. And you use this method when you can't use the disk method, obviously, when there's two functions, when the area that you're rotating is not touching your axis of revolution. So let's do an example. Let's say we have these two functions and we want to take the area bounded by those two on the graph and then rotate it about the x-axis by 2 pi radians. So first let's draw what it's going to look like. 4 minus x squared is going to look like that, and then y equals 3 is going to look like that. And my drawing isn't perfect, but you get the idea. And this is the shaded region that we're rotating about the x-axis. And it's kind of hard to draw a visualization since it's 3D, but just think about it as your normal disk method. Like it's going to be like a sphere, not really a sphere, but similar to one, and then there's a hole through the middle horizontally. That's this part. And anyways, you just use the formula that we discovered earlier in the video. It's going to be pi times the definite integral from a to b of f of x squared minus g of x squared, right? But first we need to find what a and b are, because we're not given them. But we already know that they're going to be the parts where they intersect, because we're taking the area bounded by these two curves. So we just set 4 minus x squared equal to 3, and doing the math you can get x equals -1 and +1, so those are our bounds. And to figure out what's your f of x and your g of x, or what function you need to subtract from the other, just take the one on the top in your area and then subtract the one on the bottom. So the one on top in this question is 4 minus x squared. So 4 minus x squared minus 3 squared dx. And then you can plug that into your calculator or use the fundamental theorem of calculus, but you should get 136 pi over 15 units cubed as our final answer. Now, let's get into some practice problems. If you think you know how to do this one, pause the video and try it. This one says find the volume of the solid generated by rotating the region bounded by y equals 2 and y equals x squared minus 2x plus 2 about the x-axis. So first, we need to find what our bounds are, or the a and b in our definite integral. And again, we can do that by setting these equal to each other. So x squared minus 2x plus 2 equals 2. x squared minus 2x equals 0. X times x minus 2 equals 0. So x is 0 and 2, which are our bounds. So the formula is going to be pi times the definite integral from 0 to 2 of whatever minus whatever. And to find which one you should put first, again, you just find the function that's on the top. And we can do that by just taking any x value in between our bounds and then plugging it into both. So let's try x equals 1. Well, for this one is obviously just 2 because y equals 2 always. So 2, and for this one is going to be 1 squared, 1 minus 2 times 1, which is negative 1 plus 2. So that's 1. So 1 is smaller than 2, which means that this one is going to be on top in this region. So it's going to be 2 squared minus x squared minus 2x plus 2 squared dx. And then you can plug this into your calculator, and you should get 64 pi over 15 units cubed. And that's our final answer for this problem. Now, let's do another practice problem. If you think you know how to do this one, pause the video and try it. This one says find the volume of the solid generated by rotating the region bounded by y equals 4, y equals x squared, and x equals 0 about the line x equals negative 2. And I kind of discussed a trick in the last video where if you have something rotated about the line y, like x equals negative 2, where it's a vertical line, then you can switch the y's and x's in every single equation and it will be the same answer. So this becomes y equals negative 2. This becomes x equals 4. This becomes x equals y squared. And we should probably rewrite this to get y equals square root of x. So y equals square root of x. And this becomes y equals 0. And you might think y equals square root of x is not the same as x equals y squared. But since we're being bounded by y equals 0, it doesn't make a difference because since this is bounded, we're only taking the positive. So yeah, this is the exact same. And also, you can move everything up to units because since this is the line y equals negative 2, you just move this up to units. But just make sure to move everything else to units up as well. So this becomes y equals 2. This becomes y equals square root of x plus 2. So y equals square root of x plus 2. Now we can do our formula, but first we have to find out our bounds. We already have one, which is x equals 4. We know this is a bound because it's a vertical line, but we need to find when these functions are equal or when they're touching. So when you set them equal to each other, you can just do it mentally. Obviously, x is going to be equal to 0 because square root of 0 plus 2 is 2. So it's pi times definite integral from 0 to 4 of whichever one is on top. Is it y equals 2 or y equals square root of x plus 2? We can take a number between 0 and 4 and then plug it into both. Let's try x equals 2. Y equals square root of 2 plus 2. That is going to be greater than 2. So this is what's going to be on top. Square root of x plus 2 squared minus 2 squared, which is 4 dx. And then you can plug this into your calculator. And then you get 88 pi over 3 units cubed. And that's our final answer. So now let's do one last practice problem. If you think you know how to do this one, then pause the video and try it. This one says find the volume of the solid generated by rotating the region bounded by x equals 0, y equals 0, y equals 1, and y equals x minus 1 about the x-axis. And you can put all of these into your graphing calculator to visualize what it's going to look like. But basically, we have the x-axis, the y-axis, y equals 1, and y equals square root of x minus 1, which is like this. So this is the region that we're going to be calculating. And you can notice something, since this graph starts at x equals 1, from 0 to 1, there's no graph of this function. We have to split our equation into two parts. at x equals 1, because for this part, this is just disk method, because there's only one function here, y equals 1, but from 1 to wherever these functions intersect, we use washer method because the region bounded isn't connected to the axis. So first off, let's do our disk method. And for every single problem, before you start it, I recommend putting every single function into your graphing calculator to visualize it, to see like if you're doing this right or if you're missing anything. So anyways, for our disk method, it's going to be pi times definite integral from 0 to 1, because that's where this graph starts, of 1 squared is just 1 dx. And then we add pi times a definite integral from 1 to wherever these intersect. So we have to set y equals 1 equal to y equals square root of x minus 1. So x minus 1 equals 1 and x equals 2. So that's our right bound of, and as you can see by the graph, we're just thinking about it or just taking a point between 1 and 2. Y equals 1 is on top, so it's going to be 1 squared minus x minus 1 squared. So I mean square root of x minus 1 squared, which is just x minus 1. That becomes 2 minus x dx. And now this is pretty easy to figure out using the fundamental thermodynamics calculus, but if you just plug this into your calculator, it also works. You should get 3 pi over 2 units cubed, and that is your final answer for this problem. So everything that I just explained in this video and all the problems that I went through should teach you everything you need to know about the washer method in solids of revolution. If you learned something from this video, or if you enjoyed it, then please consider liking and subscribing.